today we're going to take what we have learned about finding the area of a triangle, area of a parallelogram, and area of a trapezoid, and we're going to apply it to other types of polygons. And what we're going to use today are called regular polygons. Regular polygons have congruent sides and congruent angle measurements, and that's pretty important to remember here. And that's how we can use those other formulas, is because we are working with those regular polygons. Okay? Now you'll notice I haven't started with the standards that we're addressing, because it's the same standards that we've already addressed in 10.1 and 10.2. So here we have a regular pentagon with sides of length 16 centimeters. Excuse me. So what Patrick did is he divided it into 5 identical triangles. We were able to do this because a pentagon has 5 sides. I wonder if there's a connection there. So we measure the height of one of the triangles to be 11 centimeters, and now we need to find the area of the pentagon. So there's no formula to find the area of a pentagon. So I can't write something down that area equals this times this plus this, take that squared, do anything like that. So by creating those triangles, we are able to then utilize information that we already know. And we know that the area of a triangle, and I'm going to scroll this down a little bit so I have a little bit more room to write. We know that the area of a triangle is 1/2 base times height. So we know that the base of one of the triangles is 16. It's right there. Height is that perpendicular distance, so that's 8. So I take half of 16, which is 8, and then 8 times 11 is 88. So that would give me the area of one triangle. Well, 5 triangles make up that pentagon. So I would take the area of one triangle times the 5 triangles that make it up to get 440 square centimeters. Excuse me. Joanna has a hexagonal, or hexagonal, however you want to pronounce it, placemat. She measured the sides and found that they were all 9.3 inches long. That makes us a regular hexagon because all the sides are congruent. She then divided the hexagon into 6 identical triangles. She measured the height of one triangle and found that it was 8 inches, so find the area of the placemat. So again, very similar to what we just did. Okay, so I'm going to scroll this up a little bit. So we know that the area of a triangle is 1/2 base times height. So it would be 1/2 of 9.3 times 8. I know that half of 8 is 4. So 4 times 9.3. 3 times 4 is 12. Put down the 2, carry the 1. 4 times 3 is 36 plus 1 is 37. And I would have 1 digit after the decimal point. And again, that's the area of one triangle. Excuse me. So that placemat is made up of 6 triangles. So I can take 37.2 times 6. And we get 223.2 square inches. Now, if you notice on this hexagon, it could also be split into 2 trapezoids. Okay? If you were to split it right down the middle here, that creates your 2 trapezoids, and you could utilize your area of a trapezoid formula as well. I might say, but we don't know what the other base is. Well, wouldn't this be congruent to this, which is also congruent to this? And then you can utilize it that way. So if you want to check real quick, go ahead and pause here and do the area of a trapezoid. Okay? And you can see if that works. And it should if you do it correctly. All right, so go ahead and pause the video here, answer these final 4 questions, and after you have answered all those questions, resume the video, and we'll go over it. All right, so for numbers 1 and 2 here, we just had to give the minimum number of identical triangles you could divide each regular polygon into so that you could find the area of the polygon. So this is pretty simple. We can't do anything else because we aren't given any dimensions. So we can see Bethany, our young lady over here, gives us that count the number of sides in each figure. Well, number 1 is a pentagon, and so we'd come out from the center to each vertex, and that would give us 5 triangles, just like the pentagon we had earlier. Imagine that. Number 2, we have a hexagon. So again, we're going to come out from the center to the vertex. And I wonder if it'll be the same as the hexagon we just had. Look at that, it is. We have 6. And if you haven't done these 2 yet, pause the video and work those, and then resume the video when ready. Excuse me. All right, for number 3 here, Blake drew a regular pentagon with sides of length 6 inches. So what you could do if you wanted, you could give yourself that visual and just kind of sketch a pentagon. It doesn't have to be perfect, it's just a sketch. Mine's not perfect at all. You can see that that right side, the last side I drew is a little bit longer than everything else, but it's just a sketch. And so we know that all the side lengths are 6 inches because that's a regular pentagon. Okay. He divided the pentagon into 5 identical triangles. So again, I come to the center and I come out to each vertex. He measured the height of one of the triangles to be 4.1 inches. So from here to here would be 4.1 inches. So we want to find the area of the pentagon. So again, we go back to area equals 1/2 base times height. So area equals 1/2 times 6 times 4.1. Half of 6 is 3. 3 times 4.1 is 12.3. And you have to remember that that's the area of one triangle. So to find the area of the pentagon, that's made up of 5 triangles. So you multiply those together to get an area of 61.5 or 61.5 square inches. And then finally, number 4, and we have that nice drawing of a regular hexagon there. We have lengths of 28 centimeters. So you divide the hexagon into 6 identical triangles and measure the height of one of the triangles to be 24.2 centimeters. Find the area of the hexagon. Well, I'm going to do this one a little bit different. You may have done it with triangles, but I'm going to do it with the trapezoids. And let's see if our answers match. So I know that my trapezoid can be created right there. And the area of a trapezoid is 1/2 base 1 plus base 2 times height. Excuse me. So that's going to be 1/2 28 plus 56. Remember, these bases are all going to be the same. Okay? Times our height of 24.2. So that's half of 84 times 24.2. So that would be 42 times 24.2. So I'm going to take 24.2 times 42. Need to extend that a little bit. There we go. Add those together. And then that's the area of one trapezoid. So I need to take the other trapezoid area as well. So I double that, multiply it by 2. And you should get 2,032.8 square centimeters. And that's it.